let's go. Okay, so welcome guys to day 23. Today we're solving a ThreeSum question. It's quite hard, but it's a classic, so let's just get right into it. Okay, so the question reads, given an integer array nums, return all the triplets num I, j, k, where nums I plus j plus k is equal to 0, and indices of I, j, k are all distinct. And the output should not contain any duplicate triplets, and you may return the output and the triplets in any order. Okay, and you can see that this is not ordered, but you get these two out, but you actually got 3 out, but because it was a duplicate, yeah, you kind of get the gist. Okay, so the first instinct I have is to order the array. Okay, so order the array. Then so we want to return a result actually, so I'll do something like this: list and result is equal to new list and okay, got that. Nice. And then the end we're just gonna say that we wanna return the result. Let's just make this bigger. Yeah, return the result. Okay. So what is our objective? Our objective is to return what numbers we need to add to 0 based on 3 pointers I, j, k. Yeah, they cannot be duplicates. So that's the main objective we're doing. We just want to return 3 pointers with the numbers, and they can't be duplicates. So how would we begin this? So first thing is that we need to do a for loop, just to iterate over the numbers in an array. So I'm gonna do what I is instant nums dot length minus 2 I plus plus. And one thing I don't see a lot of people explaining is, why do you do nums minus length minus 2? So usually we do nums length minus 1 to avoid out of bounds for 2 pointers. But since we have 3 moving pointers, we need to do n minus 2 instead, because n minus 1 in ThreeSum will get rid of the out of bounds exceptions we get for 2 pointers, but minus 2 is for 3 pointers, and this makes it easier to work with. Well, not easier, but it's absolutely essential. So okay, so we got this. What do we want to check first of all? We don't want any duplicate nums i's, so we do this. So if I is greater than 0 and nums I is equal to nums I minus 1, we just say continue. So if it's a dupe, let's just continue. Okay. Now we can set the left and right pointers. So left pointer is going to be I plus 1, and right pointer is going to be nums dot length minus 1. So typical, like you do this usually, and then we go over to the normal loop while the left pointer is at the right pointer. What do? So our first case we want to see is if sum is equal to 0. So if sum is equal to 0, what do? So we already have this list here. We'll list up list a list, so we want to add to it. So if sum 0 is 0, rows dot add new list, just an int, because it's a list of a list. We just want to add it in, and what we add into it, we add in the nums of the I, we add in nums what we get for left pointer, and we add in nums what we get for right pointer. Perfect. Nothing more, nothing less. Right. Next, this is really important because it's in the check for duplicates. Next, we want to move the pointers forward, but skip over dupes. So we say something like this: while left pointer is greater than right pointer, and nums left pointer is equal to nums left pointer plus 1, we're going to say left pointer plus plus. Okay. For left increment, as that is the way it moves, so left pointer that way, and we do the same for our right, but okay. But for the right pointer, decrement it as that is the way it moves. So we do right pointer minus minus because it goes like this, but skip over dupes. So while we find a dupe, just increment slash decrement until we're done. Smiley face. Okay, now we can just move the pointers like how we wanted it. Okay, that is the case that if sum is now. So now we deal with the other possible cases for sum, like if the sum, no, put on top of the if, so else if sum is greater than 0, what do we do? So if it's greater than, I'm going to minimize it, and if it's, the last case is if it's smaller than, you want to maximize it. So the rule of thumb is if greater than 0, minimize. Right pointer down. If smaller, maximize. Left pointer up. No, this is only gonna work in the case of a sorted array. Oh, I don't like that. No, only works in case of sorted array. Okay, so hopefully rows, that's a 4 leaves right here. Okay. It should be fine. Let's see how we do. Oh, sum does not exist. Why does sum not exist? Because we've never calculated the sum. My bad, guys. Sum is equal to nums I plus nums left pointer plus nums right pointer. Quite silly. Seems I defined it, but I didn't. Okay, so pass that test case. Do process. Okay, thank God. All glory to God, man. Like, we saw this question, but seeing 24. Thank you.